This section's on 7.4 partial fractions. So we're going to continue on and use what we had learned in this chapter and now use partial fractions. So partial fractions, what we're going to do is we're going to decompose rational equations. And we learned early on in this year, the rational equations are with fractions. So we're going to decompose the fraction, meaning that we're going to separate into two parts of the fractions. Another thing we're going to do is we're going to take the denominators and make it into linear factors. So with the denominator, we're going to go ahead and do some factoring involved. So, for example, example 1, we have is y equals 5x plus 1 divided by x squared minus x minus 12. So we're going to take this denominator right here, the x squared minus x minus 12, and we're going to do some factoring. So with factoring on this, we're going to do a binomial factoring, which is our two parentheses, right? So we're going to find the multiples of 12, and then we're going to either add or subtract the multiple numbers to come up with negative 1. So multiples of 12 is then 1 and 12. We also have 2 and 6, and then also 3 and 4. So if I add or subtract these numbers, I need to get a negative 1. So if I go 1 plus 12, that gives me 13. That's too big. 1 minus 12 gives me negative 11. Still not what I want. We go 2 plus 6 gives us 8. 2 minus 6 will give us negative 4. Still not what I need right there. And then we have is 3 plus 4 is 7, and 3 minus 4 is negative 1, which I need right there. So the 3 and 4 combination works for us. So again, it was positive 3 minus 4 gives us negative 1. So we're going to put that in the parentheses, and it's going to look like this. So one of the factor is going to be x plus 3. The other factor is x minus 4. Now we're going to take this, put it back into the denominator part right there, and it's going to look something like this now. So 5x plus 1 divided by the factor of x plus 3, and then x minus 4. Now, this is now going to take this right here, the fraction, and we're going to decompose it, which we said we're going to separate it into two parts of the fraction. So it's going to look something like this now. I have this a and b, and we're going to use the denominator of these fractions right here underneath each of the a and b letters. And then the numerator, we're going to set it equal to on the other side for the numerators. Now, just for the sake of just making sure our work is done correctly and is consistent, let's go ahead underneath the a, always pick the number that is the smallest. So, for example, if I have x plus 3 and I set it equal to 0, this becomes negative 3. If I have x minus 4 and I set it equal to 0, becomes positive 4. So between negative 3 and positive 4, negative 3 is the smallest one. So I'm going to put it underneath the a and put the remaining underneath the b. Okay? It's not wrong if you do it the other way, but just for consistency of making sure our work is done correctly, let's just make sure then underneath the a is the smallest one, and underneath the b is then the remaining part of it. Okay? So now taking this fraction right here, we're going to continue and use this part now. So we're going to go ahead and take this, and it's going to be now cross multiplication. Just like how we did with the inverse and also the determinant, we did cross multiplication. So we're going to multiply a times the parentheses of x minus 4. Then we're going to multiply the b times the parentheses of x plus 3. And in between it, the operation is going to be a plus. So it's going to look something like this. So a times x minus 4, that's this part right here, plus, that's this right here, and it's always plus unless the b factor is a negative, as we learned in the previous section, right? So we're going to go across this direction. So b times the x plus 3 equals, and then the numerator. Now, you're always going to put the numerator on this side right here. Okay? So we're going to continue on with the algebra. We're going to distribute the a into the parentheses, distribute the b into the parentheses, and you're going to have ax minus 4a plus bx plus 3b, and then again, it's still equal to 5x plus 1. Now, the next part is we're going to separate all the x's and all the numbers. So all the x's, meaning that ax right there has an x, bx has an x, and also 5x has an x right there. So we're going to keep it in one part, and the remaining, which is negative 4a plus 3b plus 1, we're going to go ahead and put it on the other side. So it looks something like this now, something like that, okay, where we're going to separate it. Now, on this side right here, I'm going to continue to work on this side, leave this side for right now, and we're going to go ahead and factor out an x on this side right here. So we factor out an x, that's going to have x parentheses a plus b equals 5x, and we're going to divide by x on both sides, and that's going to cancel out the x's for us. So we have is that a plus b equals 5. Now this right here and this becomes our system of equations, which we have done it early on this chapter. So we can use a couple of methods to solve for this. We can use the substitution method, we can use the elimination method, or the graphing method. Now if you use the graphing method, you're going to have to determine which one is your x and which one is your y. Most likely your a is going to be your x and this is your y. But I think this is simple enough that we can actually use the substitution method. So I'm going to go ahead and do the substitution method. So again, with the substitution method, both of these a and b have a coefficient of 1, so I can either have an a equals or b equals. Either one works out. But for now, I'm just going to go ahead and bring the b over on the other side of the equal sign, and I'm going to have is a equals 5 minus b. So now taking this right here, we're going to substitute it into this part of the equation, and we're going to continue to solve for is the a variable. So I put in the negative 4, 5 minus b, which is this part right here, plus 3b equals 1. We're going to distribute the negative 4 into the parentheses. We get negative 20 plus 4b. It's plus 4b because it's a negative and a negative, right? That gives us a positive. And then I still have is a 3b equals 1. So we're going to combine like terms now. And so we get 7b on this part right here. We're going to bring the 20, negative 20 over on the other side by adding it. And that gives us then 21. If we continue to solve for b, divided by 7 on both sides, b equals 3. Okay? So after this, on the substitution method, remember we go back, we put it in here, we substitute it into this part. So 5 minus 3 then becomes 2, and so a equals 2. Okay? So we have is a is equal to 2 and b equals 3. But wait, we're not done yet. Remember, the reason why we wanted to solve for this is to put it back into this part right here. Okay? So what we're going to do is now we're going to take this a, substitute it back into this part, and take this b, substitute it back into this part right there, and it's going to look something like this now. Okay? So that's it. For now, in pre-calculus, that's what we're going to do. As you continue on to calculus, then we're actually going to take this part right here and continue on with that problem. Okay? So that's going to be the classwork now.